Good morning, students. Myself Dr. Shantini Bhattacharya, Assistant Professor of EC Department, SRM Institute of Science and Technology, Kattanapulur, Chennai. Today I am going to start a new topic of digital logic design is master slave flip-flop. So, before going to explain the master slave flip-flop, first of all, I am just quickly recap the JK flip-flop. For this purpose, what is the principle of JK flip-flop? Actually, we know that in the case of JK flip-flop, if we consider both the input of J and K is 1, then we know what will happen. If clock is 1, that means clock is 1, J and K both are 1 1, then whatever the previous output, the just next previous output, and this is next output, this is just, it will be toggle. So if it is a 0, then it will be a 1. Okay, so that means if there is a, this is called toggle condition. Okay, this is called toggle condition. That means if clock is 1, J and K both are 1 1, then it will just, the previous output will be toggle. The previously QP is actually previous is 0, it will be, if clock 1, J and K 1, now at that moment Q n is actually the previous, here it is 1, then after again applying 1 on 1, it will be 0. In this way, if that means if I draw a clock pulse, then what will happen? So in this way, if I apply J and K and also clock pulse 1, then what will happen? That means first of all I consider it will be 0 and it will be 1. That means it is normally it is there. Okay, so this 0 will come here and this 1 will come here. So 1 1 1, that means this is 0. When all the AND gate output is 1, then output will be 0. Then here is 1 1 0, that means 1. That means if there is a 0, then one of the input is 0, means output will be 1. That means now it is 1, that means toggle. Okay, so this 1 will come here, 1 1 means now it is 0. So this actually truth table is true. So the problem is actually when there is a actually after applying the clock pulse, here what will happen, the actually continuously J and K are toggling within this clock pulse. Okay, so after completing of the full clock period, then again it will know actually clock pulse and again it will be a same. So continuously this is totally within this clock period, continuously the when we apply J and K and clock pulse is 1, then continuously output will be 0 1 0 1 0 1 combinations is there. So it is totally a unstable condition. This condition is also called the race around condition. So to avoid this race around condition, we can use the master slave flip-flop. So now I'm just go through this part. When same thing I have written here, that when both J and K input of JK flip-flop is set to 1, the output of JK flip-flop will toggle between 1 and 0, which makes the output of the flip-flop unstable. So hope you can understand at that moment what I want to say within these two lines. Okay, so this is called the race around condition in a JK flip-flop. To avoid this race around condition, we will basically apply the master slave JK flip-flop concept. So what is a master slave JK flip-flop? Here basically two JK flip-flop is used. This is the master JK flip-flop and this is the slave JK flip-flop. And here this is the one interesting thing is that this master flip-flop, you can see this is actually the clock pulse. Okay, so clock pulse is directly connected to the master flip-flop, master JK flip-flop. Okay, but In the case of slave JK flip flop, it is passing through a NOT gate. This is actually a NOT gate. Okay, so passing through a NOT gate, then it is applied. So when clock pulse is 1, this clock pulse is actually 0. That means all of you know that without any clock pulse JK flip flop will not work. So when this flip flop will work, this flip flop will not work. When master will not work, then slave will work. In this way it is actually work. So here another interesting thing is that in the case of master flip flop, when this feedback connection is not there, feedback connection is basically connected to the input of the master to the output of the JK. So this typical design consideration is actually we can avoid the race around condition. So this is actually the main circuit diagram of the master slave flip flop. Here we basically use 8 NAND gates. So you can see this is the NAND gate number, this part is actually NAND gate number 1, 2, 3, 4 is actually within the part of the master, and 5, 6, 7, 8 are the these AND gates are basically part of slave. Okay, so when basically master flip flop works, then slave flip flop will not work. It is actually work as a memory. Okay, so that means actually now here actually I am telling that when clock is 1, when it is 1, that is this one, when comes through this NOT gate, it will be 0. Okay, that means it will be at that position 0, clock is 0. So when clock is 1, then master output, that means M1 is active. Okay, is active, and this is Q, that means slave output will be act as a memory. Okay, and when clock is 0, then master output, master actually that means M1 is memory, and Q is actually active. In this way it is actually works. Okay, so when actually master by applying a clock pulse 1, when master flip flop is active, after that it just transferred this data to slave, and it actually stores this data. When clock pulse is here, it is actually 0, then it is actually works, then it actually transfer the output. Okay, so this is actually the basic concept of the master slave flip flop, and this is actually the clock diagram, that means basic diagram of the timing diagram of the master slave flip flop. You can see this is a clock pulse. So in the positive going clock pulse, QM for actually master's output, QS for slave output, QM actually work when positive clock pulse is going on. Okay, so it is also actually changes from 0 state to 1 state. So it actually continues up to when the again positive going pulse will come, then it actually again going back from stage 1 to, that means state 1 to state 0. And this is a clock output, so this is actually the negative going clock pulse. So slave actually works on the negative going clock pulse. Basically at that time it is actually when it is clock pulse comes from 1 to 0, then it's actually start working, and again next actually negative going pulse, it is start from when it is coming down from state 1 to state 0. So in this way basically master slave flip flops are actually worked. So hope all of you understand. If you have any doubt, you give me a comments in the comment section. I will try to solve it. Thank you so much. Keep watching.